And cool, maybe what we can do is like a little bit later, we can rotate it. Sweet, right? Rotate it, yeah, make it like an angle of attack. It's an aggressive word, yeah.
In the dialog boxes in PDE Toolbox, when it refers to U, is that the same as our psi?
Yes. Yeah.
Not our U velocity?
No. So the U it refers to here is what are you trying to solve for? So we're trying to solve for psi. It thinks of U as the thing you're trying to solve for, yeah. All right, so let's go and pose some boundary conditions over here. In fact, these two are probably the most important boundaries, the one on the left and right, because that's where we want to pose some kind of velocity of the fluid through those. Okay? And so we're going to go pose some Neumann conditions. And over here, I don't want no flow there. I want a flow to be there, in fact. I want it, let's just make up some number, G here on the boundary. We're going to say, hey, there's some flux across there. Let's make it like 10. Okay. And over here on this side, same thing, except now I don't want 10. I want minus 10. Actually, I'm not sure which way the fluid's going to. Let's just pretend minus. Like I said, then our plane's flying backwards, but you can't even tell where the front of the plane is. I haven't told you, have I? I could just be doing this and you say, oh, yeah, I meant for the plane to be flying that way instead of that way. Okay. Negative, but it has to be opposite sign, right? Because the normals are opposite directions on these. Okay. Top and bottom. There, I'm just going to poison Neumann, but I don't want any flow through that top bottom, so I just say, okay. And like I said, don't come back to me and say, hey, that's not exactly that fluid problem. I know. It's kind of close-ish. Okay. Which was good enough for me for right now. All right, so there we go. Now we have all blue. We've specified a bunch of stuff about the derivative of the psi. In other words, we've specified things about the derivative, which is the velocity of the field, not the stream function. That's it. Now we go to PDE. So we drew our stuff. We specified boundaries. The next button over says PDE. So we just specify, oh, it's an elliptic PDE. And we're not, if you look at what we're solving here, A is going to be 0. By the way, that's the default. F is going to be 0. Again, the default here is 10. That's the one default I don't quite understand. Why do they have 10? We're going to make it 0. And C is just 1. We're just going to leave it. This is the spatially dependent term. So you could change your del squared psi into some spatial dependence, but we're going to assume that the fluid is uniform. Okay? So C is 1 is fine. Okay. Look at that. So boundaries. So draw it, boundaries, specify the PDE, mesh it.